All right, welcome everyone to another episode of BSK Insights Podcast. I'm your host, Michael Karinian, Marketing Director at BSK Associates. Today we have the privilege of having two wonderful and distinguished guests. We have Cristiano Mello and Kerry Rodriguez. Today we'll be talking about ground improvement, a very awesome topic, very timely topic for us to talk about. And we'll see what is ground improvement. We'll start off with that. We'll talk about why it makes sense to perform ground improvement and go on to additional questions and important aspects about it. But before we begin, as always, according to our podcast format, we're going to introduce our guests to have them talk a little bit about how they got into this field, in geoprofessional field, and also how do they get into BSK Associates and what they do currently, and also a fun fact. So, of course, Kerry is our newest guest. You guys have probably seen Cristiano many times. He's no stranger to this podcast, but it's Kerry's first time. So we want to welcome her first and foremost and have her introduce herself. So Kerry, please.
Yeah, so as Michael said, my name's Kerry Rodriguez. I'm a geotechnical engineer here in Livermore, California. I got into geotechnical engineering by getting a degree in civil engineering and being a structural engineer for a few years and deciding that wasn't for me, and coming back, getting a master's degree in geotechnical engineering, and I haven't looked back since. I've been at BSK Associates since 2013, so it's been 13 years, and working with Cristiano that whole time, and also the 7 years prior to that. So we've been working together. No, 26, can't do math. 26 years we've been together working. I guess that's a fun fact about me, but another fun fact about me is in 2008, I decided to quit and not work anymore, and I stayed home with my kids for about 6 years and raised my kids as a stay-at-home mom.
Oh, that's awesome. Great story. I mean, it's interesting how the path brings folks to BSK, right? So when you start off in your field, I can basically say a story like that as well, from starting off doing marketing and different levels of marketing, but then moving into this opportunity because there is a big draw to BSK, and that is because we're an ESOP, right? We're 100% employee owned. And so that makes it so much better because today there aren't really companies that have that opportunity. And if they are, they're very rare, right? So it's always good because as we work as employees, we're really not employees. We're owners of our business. And that's where we put in our own effort and skin in the game, as the expression goes, and we are able to make things happen. And everybody has that can-do attitude here at BSK. We're sort of like MacGyvers, right? In that series, we make things as we go. And folks who know what I'm talking about, it's a fun show you can check up on. And it's essentially a person that is very resourceful, finds a way to do everything. And that kind of really does describe who we are at BSK. We find a solution to everything we do, which is so awesome. And thank you, Kerry, for sharing your story. Let's get into Cristiano here and then have him introduce himself and talk to us a little bit about himself.
Thank you, Michael, for the opportunity. And again, Cristiano, I think this is what my third or fourth podcast. Have been with BSK same amount of time as Kerry, 13 years, and about 26-year career in geotechnical engineering, primarily San Francisco Bay Area and the Central Valley. I'm a registered geotechnical engineer as well. I also serve as the managing principal for several of BSK's offices.
Awesome. Well, thank you for that intro there. Let's jump right into our conversation here. So, let's start off with Cristiano first. Why don't you tell us what ground improvement is?
Thank you, Michael. Well, it's the process, of improving, either a weak or unsuitable soil, usually in place, right? You don't remove it, you in place condition, and you're trying to improve the strength, reduce the amount of settlement. Sometimes you're also trying to reduce the permeability of the material, right? But again, the key word here is in place. So you're not removing any of that material.
Awesome. Well, Kerry, why don't you talk to us about when does it make sense to perform ground improvement?
Yeah, so as a geotechnical engineer, we have so many options and so many different kinds of foundations. We could do shallow foundations, deep foundations, all kinds of foundations, but sometimes the soil doesn't cooperate with us and it's terrible soil for one reason or another, and maybe a simple foundation doesn't make sense. And so when we improve the ground instead of doing an adaptive sort of foundation is when it makes sense economically, which is almost always the case. It really comes down to money. So, but why would we need ground improvement? It could be a myriad of reasons. So sometimes we just have terrible soils and you can't even extend, say, a deep foundation deep enough or float a shallow foundation on it. I had a whole project in Ventura County and we did CPTs down to 100 feet and it was still super soft soils. And so sometimes you have that kind of condition. Sometimes because of the design of the structure, you really want to have shallow foundations for whatever reason. And if you do ground improvement, you can do a shallow foundation because now instead of a deep foundation to get to a better soil, you improve the soil and you can use shallow foundations like, say, you had originally planned. Sometimes it's just really impractical to say if you had really terrible soils to remove the soils. And so again, if it makes sense economically to improve the ground instead of do a deep foundation, but you're in the middle, say in the middle of a city, and you can't just do a huge excavation to remove all the crummy soil, that's when you might come in and do some ground improvement. Often ground improvement is used because you're trying to limit settlement. And you can do that with deep foundations if it's a simple building, but maybe you have like a long embankment or retaining walls or something like that. You can't put an embankment on deep foundations. So you would go in and improve the soil underneath the embankment. Often here in California, ground improvement is used because there's a risk of liquefaction or, say, lateral spreading, which is a result of liquefaction. It's a very common reason to need ground improvement. And sometimes maybe one of the options is removing the soil, but you've got contaminated soil and you do not want to take that soil anywhere. You could use ground improvement in place, one that maybe doesn't create a lot of spoils and keep that contaminated soil in place. And then sometimes, last but definitely not least, it's just more cost effective to do ground improvement instead of removing the soil or doing deep foundations or doing something else.
Gotcha. Well, do you want to explain to us a little bit about what type of soils you've seen from your experience that cause some issues? You mentioned a little bit about soft soil, but are there other circumstances you want to elaborate on?
Yeah, I would definitely say, like I said, a common one here in California would be liquefiable soils, which would be, or they could be even just any kind of seismic densification or compression. So liquefiable soils tend to be loose, sandy soils, saturated, that will compact or consolidate under an earthquake load, or maybe even slide sideways if you have a free face or a sloping ground. That's called lateral spreading. And ground improvement is a fantastic way to improve lateral spreading conditions, because sometimes a deep foundation, if you put it through lateral spreading, spreadable soils, and if the soil actually moves during an earthquake, it might just break the deep foundations. So you have to actually improve the soils. And then, yes, very soft, consolidatable soils. We have something called Bay mud in the Bay Area, where it's brand new soil geologically, and it's still sort of consolidating and it's really soft. Sometimes it makes sense to do a deep foundation or maybe sort of a floating footing foundation, but sometimes it just might make sense to do some ground improvement in that case.
Awesome. And you talked about contaminated soil. So I know we deal with that often. So you want to talk a little bit about that? What happens in those cases? How does BSK help out?
Well, There are a few ground improvement methods, which I believe Cristiano is going to talk about, that
Okay.
produce very few spoils, and spoils would just be excess soil. Once you've put in your foundation or improved your ground, you have soil that now you're left with that you have to take somewhere. And so if it's contaminated, sometimes the best thing to do is to leave it in place. And there are a couple different ground improvement methods where you can, say, mix cement with it, and it sort of becomes cement and it becomes entombed instead of trying to remove it and off-haul it, which is very environmentally unfriendly for lots of reasons.
Gotcha. Well, it's a great segue into our next question here, and this would be for Cristiano. What are some of the most common types of ground improvement?
Well, depending on the site conditions, right, or the type of site, I think Carrie mentioned, if you are in a developed area, you can afford to do deep excavations, things like that. So, one that is commonly used for open space, if you will, is dynamic compaction, where literally you have a large crane dropping a large heavy weight on the ground and inducing compaction. It generates a lot of vibration. So if you're in a downtown area, you're not going to do this, not only because of the vibration, but the residents would be very uncomfortable, right? Why is the ground shaking so much? Another one that is very commonly used, and it's primarily used for liquefaction, to mitigate liquefaction-induced settlement, is vibro stone columns, right? So what you do is you pre-drill, undersized diameter hole into the ground just to kind of serve as a guide hole, if you will, and then you push down into the ground a mandrel, right, which is basically a hollow pile, and as you are pushing it to the ground, you vibrate, um, induce vibration just to densify the soil and allow through vibration for the mandrel to achieve whatever design depth you're trying to get to. Once you achieve that design depth, you open the bottom of the Dremel, mandrel, you drop your, a layer of crushed rock, you close the mandrel again, you lift it up, and then you vibrate and push it down, and you create, a number, of bulbs, if you will, compaction bulbs in a column type fashion as you extrude the mandrel to the surface. And, there's a number of benefits that are induced by that. First of all, you densify the ground surrounding the vibrostone column. You also create a pathway for pore pressure to dissipate through during a seismic event. Another ground improvement is commonly used is deep soil mixing. That is kind of what, analogy for what Carrie and you were discussing earlier regarding, if you have contaminated soils, it's better to mix that contaminated soil and try to make it stronger and leave it in place than replace it with something. Not only you have the extreme cost of off-haul of contaminated soil, now you also have to import soil to the site, right? Other methods include compaction grouting, which literally you drill a hole in the ground and you get to a certain layer and you inject grout until you create a nice bulb, and then you proceed to the next layer and you inject another a certain amount of grout, creating a bulb, and it's almost like a column-like feature, if you will. There's also rigid inclusions, which are kind of similar to deep foundations, but a lot less costly because they have less reinforcement, if any, type of thing. There is also one that I consider more like a temporary, ground improvement, which is ground freezing. I have only seen used in one of my projects where we were excavating having a large excavation for a water treatment facility next to a major river. and the subsurface conditions were predominantly gravel and sand, and you don't want the river to literally, start discharging to excavation, right? So the contractor used ground freezing and kept the ground frozen throughout the excavation. And after the excavation, they stop freezing. It reverses to original conditions. Kerry, did I miss any of the typical ground improvement methods that we have seen in the past?
Well, that sounds about right.
All right.
I think you
There you
covered
go.
it.
You passed it, Cristiano. So great job.
Thank you, Michael.
You get 2 thumbs up. Well, let's move on to the next question, which connects with what we just talked about, and that is, what are the 2 common types of ground improvement specifications and their pros and cons? And I think Carrie can answer that one.
Yeah, so a specification is just sort of a big long document that tells you how to build something. And there's 2 different ways of approaching ground improvement. So one is called a method-based or a prescriptive specification. So this is essentially somebody saying, hey, we're going to use, vibrostone columns, and we're going to space them every 6 feet on center, and we're going to go down exactly 40 feet, and the vibrostone columns are going to be exactly this diameter. And that's what's put in the specifications. And that can be helpful because it's clear and straightforward. Everyone understands that. You don't really have to understand ground improvement to understand that. The owner or the designer doesn't really have to be technical or know what is being built, and it simplifies the bidding comparison. So you've got 5 contractors that are trying to bid for the project, and they're all pricing the exact same scope. Everybody knows exactly what the scope is. The cons, though, is that there's no innovation or optimization. Everybody knows they're supposed to be 6 feet on center and they're 40 feet deep. And so improving, alternate methods or improving means and methods are not allowed. So you may get sort of a conservative or an inefficient method that's not optimal for the site conditions. The other, and also the risk remains with the owner, or even maybe the geotechnical engineer who the owner hired, not with the contractor. So with a performance-based specification, this is specifying what's the outcome. What's the minimum shear strength? What's the allowable settlement? Say if we're worrying about permeability, like Cristiano's freezing project, what's the maximum permeability? What is the maximum potential liquefaction settlement? And so that leaves it on the contractor to choose and design and construct the project. And the contractors out there doing this kind of work, this is what they do for a living. They have people on staff that they are pros at this. They teach everyone else how to do this stuff. This is their job. So the pros of this is really it encourages innovation and a best fit solution for the project, for the site conditions. It's often more cost effective, especially as complicated as the project gets. They may choose multiple improvement techniques. And the risk, importantly, goes onto the contractor instead of onto the owner, because they have the responsibility and they're not going to over design or anything like that. The cons are it's more complex to develop and review, and everybody has to decide on what the performance criteria is. Say if it's a CPT that you're going to be pushing to estimate the potential liquefaction after all the ground improvement is done. Everyone needs to be on the same page. It also requires the owner or the reviewer to have some technical expertise, or more likely to hire a trusted and knowledgeable geotechnical engineer to review everything. And when you're sending it out to bid, it makes it really hard to compare the different, the different approaches, because they could be totally different. And so if you're not knowledgeable, you may not know what you're getting. You have to trust in the specialty contractor.
Awesome. And I think that really puts us into the next question. And Cristiano, I think you can answer this. What is BSK's approach to providing ground improvement recommendations?
Well, once we have established that a particular project or site is suitable for ground improvement, right, we will include preliminary design recommendations in the text of the geotechnical report, right? Then if the owner decides to proceed forward with the ground improvement as opposed to more traditional methods like deep foundations or, other approaches, could be over excavation, if it is feasible, right? At that point in time, we look, usually there's two different approaches that can occur, right? One is if you have a publicly funded agency type project, where the owner is a public agency, right? Usually they want to go through the bid type approach, right? Versus a privately funded project where the owner has the flexibility to decide who they're going to use upfront, not undergo any kind of bidding process. Maybe they already know somebody, or they have a strong referral from the design team, or they have prior experience with successfully installing ground improvement with a prior contractor. They want to use that contractor, right? So depending on which approach is used, right? As far as BSK is concerned, let's say it's a public agency, right? What we will do is we will engage with a reputable specialty contractor, ground improvement specialty contractor, and get their help in preparing the performance-based specifications, right? These folks, right, they are experts in what they do, right? And we try to create a generic enough performance-based specification that multiple contractors can bid on, right? Because some of the methods out there, they're proprietary, right? If you specify a certain type of ground improvement and only one contractor in the world can do that, well, guess what? You're going to get one bid and might as well hire the contractor up front, right? And so we help the design team with the preparation of the performance-based plans by engaging with a reputable contractor. The other option, right, is if the owner hires upfront the specialty contractor, they will have a chance to review the geotechnical report, hopefully prepared by BSK and Associates, and we can provide input to the design, to the specialty contractor to finalize their design, right? At the end of the day, either approach, the specialty contractor, right, is the responsible engineer as far as the design of the ground improvement, right? BSK, if we're involved, we're the geotechnical engineer for the overall project. But when it comes to the ground improvement, whatever specialty contractor is designing and building that, right, they're responsible for, okay? So once the plans are prepared, right, project goes to bid, then it goes in construction. Similar for if the ground improvement contractor is hired directly by the owner up front. Again, once it goes into construction, BSK, our approach is to assist the owner as well as the design team to confirm that the objectives of the ground improvement are being met, right? How do we do that? One of the things is we review submittals by the ground improvement contractor. It could be a set of plans saying, hey, the grid pattern for the ground improvement is this. The geotechnical report initially recommended ground improvement to 30 feet. We have extended to 35 feet based on our analysis, and here's why. And we'll review that and provide comments. Very often we defer to the special contractor, right? But very often we'll ask some specific questions that just to help them in the process. Have you considered this? What about groundwater? Did you assume that this is the level, or did you make it variable, or what? Did you change any of the parameters depending on what portion of the site? If you have a fairly large site, there may be differing conditions as you move around the site, right? Then, when the ground improvement is actually being performed, right, BSK can help the owner by being on site, observing the ground improvement operation, making sure the Prince's recipe is being followed, right? If the ground improvement contractor said we're going to do 700 vibrostone columns, 36-inch diameter, 8 feet on centers, to a depth of 30 feet, is that being followed? And if it's not, why was the change? Maybe they hit an obstruction at a location. Well, if they hit an obstruction, should an additional column be installed nearby? Can that column be eliminated? Those are the questions we can help the design team and the owner answer during construction, right? And then finally, what Kerry had alluded before, what kind of verification testing is going to be performed after the installation of the ground improvement, right? There's like several options for that. The very common verification tests that are performed, one she mentioned, CPTs, cone penetration tests. And what you do is you have the pre-ground improvement CPTs, which are performed usually during the geotechnical investigation. They give you a snapshot of what the site looked like before the ground improvement. And then you have what's called a post CPT, right? And it may be more than one. It might be, I have seen 2, 3, 4, 5, really depends on the site. The last site I did was only 2 on opposite ends of the building pad, and that was suitable. And again, that was part of the submittal process. The contractor said, we're going to do 2 at this location. Is that okay? And as a geotechnical engineer for the overall project, I said, yeah, that's reasonable. No exception taken. They were intentionally pushed next to previous CPTs, right? Because again, you want to be able to compare things. But other types of ground improvement verification tests include a plate load test where you have a large steel plate and you're just pushing the ground to see how much the ground settles. You also have modulus testing, which is very similar to pile load testing, where you have a reaction block and then you have a device that loads the ground, and you measure the deflection, and you are trying to confirm that the deflections don't exceed a certain maximum value, right? Just to make sure that, hey, indeed, settlements will be limited to what the design team has requested.
Well, it sounds pretty extensive, and obviously we have the expertise to go through each and every part of the process and all of these steps that we implement. But I really would like to find out, what would you say, or what type of clients normally are a good fit? What have we seen? And whether it's institutions or private companies or whatnot, what are some examples as far as work that we've done within this specific area?
So a lot of the projects that I have been involved with have been wastewater treatment facilities, right? Usually they have, they're not located in the best locations. They're near the shoreline or near, downstream, if you will, of everybody else, right? So they may be proximate to potential liquefaction induced soils. They may be near the bay, where bay mud likes to be located at. So I have also done a commercial development for a storage facility, again, near the bay, near liquefiable soils. And more recently, we did participating in ground improvement for a multi-generational recreation building.
That's awesome.
Yeah.
Well, Kerry, anything else you want to add? Any other thoughts regarding ground improvement?
No, but I think Cristiano's a great expert. So if you need a project like this, give him a call because he's got quite a bit of experience. And yeah, I don't know. Even in the past 13 years here at BSK, he's done multiple projects. So he's your man.
Awesome. I love that plug.
Thank you for the
Man, I was
confidence,
waiting for
Gary.
the very end to do that, but Gary, you did it perfectly. So again, folks, we today we covered ground improvement, and I hope you were able to catch this opportunity, go in depth. If you are somebody or a company or institution or whatnot that are looking for services here for support as far as ground improvements are concerned, I definitely think it's a great opportunity for you to connect with our BSK team. We'll provide some information at the very end on how to connect with Cristiano and with Kerry, and be able to talk about your potential opportunities of what is to come. If it's something in the future, if it's now, if you need help with anything, BSK Associates is definitely here to help you out. So we want to thank you for tuning in with us and going through this very fascinating topic. I know I learned a lot. And I want to thank our two guests, Cristiano Mello and Kerry Rodriguez. Thank you so much, folks.
Thank you,
You're
Michael.
welcome. Thank
All right.
you.
Thank you.